the work we started yesterday. If you remind, we were just reading and writing a file, but using the Java 8 style, and uses streams in the like here, and lambdas, expression like this one for reading and implementing some features. I remind you that we have 8 steps to fulfill. In the first 5, we just read the file that we have to. We read the file that we have to read, and create an array list that contains our data. In particular, our data are the Daubels numbers, and now we have to sum the data in each bag, print the result, and write the result. This is what we accomplished here in main-D. As I told yesterday, this happens mostly in the main file. I still have not engineering anything. I'm just doing the operation as they comes. So we are actually here at point 7. And the point 7 was just printing the results. Printing the result the results is simple in Java 8. Sums here is an array list of doubles, which contain the sums for each lines. So what I do is I apply the same paradigm that I used yesterday. In particular, I take the sum, I transform it into a stream. Then I apply the loop on the stream for each, and I use the println of system out. So on each element of the streams, I apply system out println, because the element of the streams, it happens that it works. Oh, sorry, here. Let's make it larger. The larger, the better. So you see here that printing this stuff actually doesn't require any complicated thing. Once we have an array list, and using streams is very trivial to print all of the elements. If you want a more accurate control on the printing, on the formatting of the printing, obviously we have to act in a different way. The 8 is writing the file. So for writing the file, we have to issue the name of the output file, create the new file, and checking if the file exists. This is I just am avoiding that to overwrite an old file and preserve it with the .old extension. And here I just print the name of the file on the console. Now I have to write the file and I use file writer to do it. I actually don't remember what I did yesterday, but probably I did with a different class. File writer is a class that allows you to write files. There are other classes that allows to do the thing. I have to write the header file of the resulting class, and so for doing it, I simply put the header string. Here, as you see, is the first line plus the second line, and the two lines are comments, and so they are they have the diesis symbol at the beginning, the hashtag at the beginning. For writing, I just instantiate a file writer, which I call output file writer, just to say that is the output. And I also create a print writer, which is the print writer get as input an object which is a file writer. So as you see here, I take print writer take as input output file writer, which is an object of type file writer. Printing on the file now is very easy, very simple. I just use the method print of the print writer, and I can print any string. And in fact, I print this one. One thing that I forgot to say is that here you have /n, which is going to a new line. Now I want to write the sums in the new file. So I take the vector, the array of sums. I issue a stream here, start a stream, and then for each element of the streams, I implement a lambda, which is s. For each element s, please print. What you have to do is to use the class printf, which is formatted printing. Is very similar to the command that you have also in the C language. There is this method that acts on the class print writer, actually on the object print writer. And with printf, I can write, I can give explicit, I have to give explicitly the string of formatting. %f mean you have to place a floating number here where there is %f. You can have also %d for putting integers, and other type of formatting of the printf command that you can find in the documentation of printf, which is pretty general because it's the same. This comes directly from the C language, so nothing especially new. And then you have to put in order the variables. S here in particular, you put what the method does, take this S and place it here, and then put a new line character. I open the print writer, so I have to close also the print writer here. I think that you can imagine that if I execute the stuff, this works. And finally, we see the result. Here you see the whole set of data, including the number of lines. Here, this second command is just the crude, the naked numbers, And this is now repeated here. And finally, here I calculate the sum for each of the lines. Here I am echoing on the console the results, but could be interesting for us to go and see the results in the output file, open file, simple output file, and this is the file that I wrote. I don't need even to open the file here, but if you want, I can do it. Okay. And that's more or less all for this thing. So what we saw, summarizing what we saw yesterday and today, was how to open a file, read the contents of a file, doing some operation of the contents of the file, and finally writing a file as output. Differently from what we did before, I tried to do all this stuff using Java 8, and in particular, I used the streams and the lambdas, which are two new concepts introduced in the Java 8 language that are not present in version before Java 8. At the present time, most people here that I know program using Java 8. But as you see, can be really convenient to use Java 8 also, because if you compare, this is the main C Java, the one that contains all. No, this sorry, this doesn't contain all the things that we need. Is Java D, what this contains all, and we have 120 lines. Main B is the same concept with the traditional way of writing, and here we have 136 line. So Java 8 is much more concise in writing these things. Obviously, we need to be we cannot put streams and lambdas everywhere now just because we introduced them. We have to understand when it is convenient to use them and when it is not. What is contained then in main E? Finally, I try to do some engineering on the whole code and take out from the main some groups of commands, creating in case some methods that are used inside reducing the command. Here you say Java D. Here, for instance, here I have when I do the operation of opening a new file and writing a new file, I am taking all this code. I want to take this code here and put this code in a method. But first, let's go and to analyze how the new main is. Okay, here we have the output file. We have the creation of a get double underscore one object, which is actually the object that contains our data. In particular, we have created a get double underscore one text object. We use we set the file name of that we want to read, and we actually read the file with the for command. So let's say this command says put the file name here and read the data. At this point, you can see that actually working with Java 8, okay, one thing that I forgot to say is that here we have 120 lines, but there are some operations that I repeated twice or 3 times just to show small variation on the concept. As you see here, essentially, I don't really need to create many other methods that are not already contained in getAubel1 that we already see before. In fact, write to file was already created before, actually, and we use it here. And the use of the piping structure of these commands make it superfluous to separate, maybe to take this code and put in a single method. So filtered data simply collect the data in a unique command, a unique sequence of command. I return here, I declare here filter data 2. At the same time, I populate it and creating the space starting from the text. Red data, text red data test is the contents of the text variable. I make of it streams. I filter the lines that start with the hashtag. I skip a further line, the one which contains the 3 value, the number 3. And finally, I collect in the results in an array list of what? Of strings. So now I have an array list of strings. I create a new array list of doubles, which just contain the sums. And here I use maybe the only one method that I was compelled to create, which is string to sum. So I take the filtered data, I made a stream, and in each one of them I do the sum of the results, and the sum of the results, if you want to see, is string to sum, text to double, string to sum is this code here, but this is exactly the same that we see before. Itself, this code is done in Java 8, and we do a lot of operation that I described yesterday. And if you want, I repeat today. At the same time, I declare a list of strings. I say that here I allocate a new array list of strings in which each one of the strings derive from the initial strings, one separated by blank spaces, which is this expression here between the quotes. The second command is I take the result, which is called stlist, which is a list of strings. I stream the list of strings, and I do the mapping to doubles, creating an array. Finally, I store the complete result in the sum variable, this one. And how I do it? I take the list of streams, open streams, map to double, and I apply the sum. Actually, this command here is I could equally do like this command because it's not okay. It's not really used inside here. Certainly, if I also this one here is not useful for anything, so I can cancel also this one. Was just a relict of the previous code. To be sure that it really works like I am saying now. Okay. I actually, you see here that all the printing is now disappearing because I actually cancel with the operation that I did, but we can see if we have the simple output file written again and say here, okay, it was not written, so I actually throw away the kid also with the. It's dangerous to do this operation like. Okay. So let's take back these ones. Okay. Now it does everything as correctly required, and the sums are appearing here. Okay. I was canceling something more than I was supposed to do. Printing is easy. We already saw how to do. We take the sums, text sums, which is this array. I transform it in a stream, and on each of it, I apply system out println. And in this case, there is a difference between the cases that I used before, because I give also an argument to println. In particular, the argument is the sum is and the name of the sum. So whenever we go to this is producing these three things. Here we have the name of the output file. And finally, we use here, we aggregate the whole set of commands for writing a file in this simple method here. Write to file. Text write to file. And if we go to get double one, write to file is this piece here that I already commented a few times in this lesson. So maybe it's matter of taste, but I like more this way to do these things than the original one. But in any case, you obtain the same results in with two different methods. This means that Java actually grew over time to a complex language that has several options for doing things. And one interesting thing would be to measure the performances of the two different approaches. Here we don't have any particular problem with efficiency, but obviously if we were doing calculation for which we repeat these calculations millions of times, we can accumulate differences in execution time that can be relevant if we use one approach or the other one. So when we will go to do some numerical calculation, we have also decide besides what you like to do more. And for instance, I say that I like to do more this way than the other way. Which way is more efficient? And probably the other is more efficient in several cases. Talking about efficiency, anyway, you have also to account for the fact that you have the efficiency of the computer, but the efficiency of the computer is the limit only when you are using you are a user of a program, and the program doesn't treat in a huge amount of data. It's much more important your own efficiency as a modeler, in particular for a hydrologist. They may be sometimes writing with using Java 8 instead of using previous Java paradigms or way to programming. Is less prone to errors that it used to be the other code. So you code actually faster also, and that's can be important for you. I think that I've finished now, and for this part I have nothing else to say.